see it says calcium nitrate decomposes on heating according to the equation, eh? Okay. So calcium nitrate decomposes on heating according to the equation. So this is the equation that we have. So you have calcium nitrate giving us calcium oxide, nitric oxide, and oxygen. Okay, and I want you to pay attention, especially on this particular question. Okay, can you still hear me? Are you guys there? Can you get me? All right, thank you very much. Okay. Okay, yeah, so we have this question here. The question says copy the equation and balance it. Eh? So the first thing that the question wants for us to do is just to balance this equation. Eh? Okay, so we are only required to balance this equation. Okay, so let us balance the equation. So we have calcium nitrate here. Okay, so let's see, calcium atoms here, we have one calcium atom. Also here we have one calcium atom. Oxygen atoms, how many oxygen atoms are here quickly? How many oxygen atoms are here? How many oxygen atoms are here? 6, right? So the number of oxygen atoms, you multiply 2 by 3, that gives us what? 6, okay? So there are 6 oxygen atoms here. And this side, how many oxygen atoms? 2, 2, 1, 5, okay, isn't it? So this side you have 5 oxygen atoms. For nitrogen, how many atoms this side? 2 multiplies everything, isn't it? So 2 multiplies everything here. So this makes the nitrogen atoms 2. Okay. So here we only have 1. So the first thing we would try to do, especially in this case, let's try first to put let's try to put a 2 here. Okay, try to put a 2 here. Let me do this. Okay, let's try to put a 2 here. This makes oxygen how many? 4, 5, 6. Okay, so this one is not going to work. So I think let's disturb. Let us first of all, let's say if we can put, let's disturb this side. So once we disturb this side here, meaning we should also disturb this side. 2 calcium, 2 calcium. Okay, now this now has changed everything. Okay, this has changed everything. So we're going to put a 2 as well here. No, not a 2. Let's first check. Nitrogen, now there are how many? Yeah, we're putting a 4 here. Okay, we put a 4 here. Let's now balance oxygen. Eh? Oxygen 6 by 2 is how much? 12, right? 8, 9, 10, 11, 12. Is it balanced? A second opinion to confirm it's balanced. Okay. So to go through it again, 2 atoms of calcium, 2 atoms of calcium, 2 atoms, nitrogen, 4 atoms, also 4 atoms of nitrogen, oxygen 6 plus, by 2, 12, 8, 9, 10, 11, 12, balanced. Right? So this is the balanced equation that we're supposed to write here. Okay. So follow-up question, calculate the relative formula mass. Calculate the relative formula mass of calcium nitrate. Calculate the relative formula mass of calcium nitrate. How do we find the relative molecular mass for calcium nitrate? Anyone with an idea? Anybody? Anyone with an idea? Okay, we're going to get this one. Okay, so we're going to get calcium nitrate like this. How do we calculate for the relative formula mass? How are we going to find the relative molecular mass? Anyone with an idea? Correct, 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 correct. Okay, so how many elements do we have here? We've got, first of all, we have calcium, and for calcium we have one, here. Nitrogen, how many are they? Two. Oxygen, there are six. So times, yes, please. Okay. Okay, so when calculating the relative formula mass, you don't get the coefficient, okay? Yeah, so don't get the coefficient. Okay, what's the mass number for calcium? What is the mass number for calcium quickly? 40. The mass number for nitrogen? What's the mass number for nitrogen? 14, eh? Mass number for oxygen? 16. Yeah. Okay, let's sum up. Let's find the products. 40, 28. What do we get? 16 multiplied by 6. What do we get? What do we get? Let's add the totals now. 1, sorry, 164. All right. What are the units for relative formula mass? Yeah. Okay, it is grams per mole. Okay, it is grams per mole. Okay. All right. Okay. Uh, question C. 16.4 grams of calcium nitrate is decomposed. Calculate the volume of oxygen gas liberated at room temperature and pressure. So here we're going to go to the balanced equation, which is this here. Let's just write it again here. The balanced equation, we have calcium, calcium nitrate. Okay. Yes, we are getting the balance. Okay, that's the one we're getting. Okay, we got calcium oxide plus nitric oxide. Okay, then we said here was a 2, not so. Here 4, not so. Okay, so we have this one here. We have 16.4 grams of calcium nitrate is decomposed. Calculate the volume. So the volume of this. So first of all, we're going to do a mole ratio between. So this is when now you get together with the coefficient when doing your mole ratios. Okay, when doing your mole ratios, you are picking the coefficient. So the coefficient here it's 2, the coefficient here it's 1. Now you need to calculate the moles here. Let's calculate the moles. we know that mole is equal to mass over molar mass or relative molecular mass. So the mass is 16.4 grams. Then what did we find for the molar mass? Because one we calculated in our previous question, which is 164 grams per mole. Okay. Somebody to calculate this for us. Anyone to calculate this for us? Yes, please. Yes, yes. No, just the previous one. For molar mass, the coefficient you only use it when doing your mole ratio. Eh? That's a good question. We're together. All right. So what do we get now for the moles? What do we get? Somebody to divide 16.4 divided by 164. Quickly, quickly. 0.1. Okay, so these are the moles for this. So you put it here. Here, just say x. Then we cross multiply. This and this, you get 2x, 0.1 more. Dividing both sides by 2, what do we get? Quickly, anyone? 0.1 divided by 2. Okay, so these moles now, they belong to which one? Yeah, they are the moles for oxygen. And the question now wants us to find the volume of oxygen. Eh? So for the volume of oxygen, we say 1 mole of any gas is equal to 24 cubic decimeters. Eh? So we pick the moles of oxygen to find the volume. Cross multiply here. X will be equal to what? 24 multiplied by 0.05. What do we get? What are we going to get here? Okay, so that's the volume. Okay, so the key or the take-home message here, starting from where the question is starting from, the take-home message is that the first thing, that's why question 1 here asks us to balance the equation. Now, if your equation is not balanced, all your calculations will be wrong. Okay, you need a balanced equation. For this one, remember, don't use the coefficient for the relative formula mass. Okay, here again, where you need to do calculations involving moles, you need to go back to the balanced equation. Eh? Okay, do we have a question here? Do we have a question here? Everybody clear? Okay, thank you. We go to the next question. The next question says, it's question B6, 2022 paper. The following elements with their electronic configurations are in a certain group of the periodic table. So the first element is W, the second X, Y, and Z. Name the group in which these elements belong to. Okay, so just by looking at the electron configuration, can we tell? Group 8, correct? So this is group 8. Now, if this is group 8, um, if this is group 8, okay, this is group 8, like we've said. What made you identify them? The answer is very much correct. It's group 8, but what made you identify them? Okay, the last number in the outermost shell. So you can see 8, 8, 8. Now, this one is also in group 8, but then it is special. Okay, this one is special in a way that it only has one shell. That's the reason why there are only two electrons. Okay, yeah, the answer is correct. Yeah, the answer is very much correct for this one. It is group 8. Okay, group 8. Some they'll say group 0 or group O. What accounts for the chemical unreactivity of this group of elements? In other words, that's very correct. It's because the outer shell electrons is filled to maximum. This one is full. This one is full. This one is full. This one is full. So all these, number one, they are stable. Okay, they are stable to outermost shell. Outermost shell is full. Okay, capacity, it's filled to capacity. So they can't lose, neither can they gain any more electrons. Okay, very good. C. W is used in weather balloons. Explain why W is the most suitable in weather balloons. First, before we even explain why it is suitable, what is the element W? Okay, that's very precise, very correct. Okay, very precise, very correct. It is less dense than air, and it is also safe and stable because these are unreactive. Okay, so it is less dense than air, it is safe and stable. Okay. Describe the density or describe the change in density as you go down the group. Anyone with an answer? Okay, that's very correct. What do you think is the reason why? What do you think is the reason why? I like that answer. Can you just repeat it? That's a very good answer. Very good answer. Very correct. So it's due to the increase in atomic mass and atomic radius going down the group. Why they become, just look at them here. It starts like this, one shell, two shells, three shells. Going down the group, they increase. That's very good. I think that was Edna. Edna, wonderful.